Okay, last example. If tangent of theta is equal to -3 over 2 root 5 and cos of theta is positive, then find the value of sine of theta. All right, so we're going to sketch this, try to figure out which quadrant we're working in. So when we're starting to sketch now, we always want to consider our cast rule. So looking at the ratio it gave me, it tells me that this tangent ratio is negative. So that tells me that this can be drawn in either quadrant 2 or 4, because 1 and 3, my tangent ratios would be positive. So that tells me I'm going to draw this either in this quadrant or this quadrant. But then it goes on to tell me that cos of theta is positive. Well, the quadrant in which cos is positive would be 1 or 4. So the quadrant that I'd have to draw this in, right, that would make both of these statements true would be quadrant 4. So I'm going to draw my triangle. Here's my angle. Tangent, remember, is opposite over adjacent. So my opposite over adjacent. So the opposite would be 3, and because we're in this quadrant, 3 would have to be negative, and the adjacent would be 2 root 5. So now we're going to use, it asks us to find the value of sine of theta. Well, to find the value of sine of theta, we need to know the radius or the hypotenuse of this triangle. So we're going to take a 2 root 5 squared using Pythagoras and solve for this r value. So when we do that, this works out to a value of 29. So our r value as an exact value is going to be root 29. I'm going to look to see if I can try to simplify this, break it down, and it cannot. It's going to stay a root 29. So now we're going to write our sine ratio. So our sine ratio for this is opposite, which is -3, over the hypotenuse, which ends up to be root 29. Again, we do not want radicals in our denominator, so we're going to multiply the top and bottom by root 29. And we end up with a -3 root 29 over just 29, because this times this, basically these roots cancel each other out. And that's it. That would be the answer.